Here is an explanation for the answer to final exam question number 13 in Electricity Demystified, second edition. Please see page 323. We have a transformer which has a step-up ratio of 1 to 2. That's the turns ratio. That means the secondary has exactly twice as many turns as the primary. We put 120 volts RMS AC into this primary winding, just what you would get out of the standard utility outlet in the United States, 120 volts RMS. That will produce 240 volts RMS here, because the voltage transformation ratio is the same as the turns ratio. But our question is asking us about peak to peak. Well, the peak to peak voltage is going to be 2.828 times this RMS voltage. And when we work that out, we get 679 volts peak to peak across this winding. 2.828 times 240, rounded off to 3 significant figures, is 679 volts peak to peak. And that is choice A. If you wonder where this factor of 2.828 comes from, that's actually an approximation of 2 times the square root of 2. The positive or negative peak voltage, assuming there's no DC component in this, is the square root of 2 times the RMS voltage. So the peak to peak would be the positive and negative peak combined, twice either one of them, so it would be 2 times the square root of 2 times 240. That's the exact number in theory, assuming we have a perfect sine wave with no DC component. But again, the correct choice here is A.